All right, team, grab a seat. Let's get right into it. Think of me as your senior engineering mentor for the next few minutes. So, we've been handed this massive task, right? Taking NovaCart, our basic, somewhat clunky e-commerce customer service chatbot, and upgrading it into a fully autonomous, multi-agent system. Well, you're exactly where you need to be. Today, we're doing a deep dive architecture analysis in this explainer. We're going to break down exactly why agents crash and burn in production, and more importantly, how to fix them using 6 battle-tested coordination patterns.
Here's our game plan for this sprint postmortem. We're going to quickly cover production chaos, then dive into our 6 architecture patterns, show you how to build a highly available stack for under $50, go over 5 fatal errors you absolutely must avoid, and wrap up with an immediate action plan.
Okay, let's kick things off with Section 1, Production Chaos.
Now, I need you to really hear this first point because it's a game changer. Your LLM is almost never the reason your agent stack crashes. I know it's easy to blame the model, but according to a 2026 technical breakdown by GitHub's engineering team, most multi-agent failures trace back to missing structural components. It's actually about agents making implicit, unchecked assumptions about state, ordering, and validation. The model itself? It's fine. It's the lack of structure around it that's going to burn you.
68%. That is a staggering number. That's the failure rate of multi-agent deployments within just their first 72 hours. Why? Because teams are essentially building houses on sand. You need to watch out for the early signs of an imminent system failure. Things like silent loop drift, where an agent just retries an action endlessly, or stateless handoffs that cause massive context loss between steps.
We call this the stalled pilot syndrome. You know the drill, right? Running NovaCart locally on your laptop, it looks like absolute flawless magic. It's cheap, the logic is perfect, but in a production environment, those stateless handoffs completely destroy your hard work. Suddenly, you've got agents stuck in infinite URL loops until you're hit with a $200 API bill at 2 a.m. Or worse, 2 agents blindly write to the exact same database row and corrupt 6 hours of customer data. Remember, we are building a distributed system now, folks, not just a fancy luxury chatbot.
Which brings us to Section 2. Let's look at the actual fixes. 6 architecture patterns.
Pattern 1 is the orchestrator worker setup. This is how you prevent your agents from going totally rogue. Think of it like a strict military command structure. You have one lightweight orchestrator that reads the main goal, breaks it down into atomic tasks, and dispatches them to specialized workers. The crucial part? The workers never talk to each other directly. They only report back to the orchestrator. This eliminates that production chaos right from the start and drastically reduces token waste because every agent has a very strict, narrow focus.
Pattern 2 is the stateful blackboard. Instead of blindly passing data down a chaotic chain, agents read and write to a shared canvas, something like a Redis cache. Agent B reads exactly what it needs from the blackboard, writes its own results back, and that state change is what triggers the next step. This completely decouples timing. Actually, in a recent real-world case study, using this exact pattern allowed a team to process 14,000 documents a month without a single context collision. It literally stopped silent hallucinations in their tracks.
But hold on a second. If you have all these autonomous workers generating data, who's making sure they aren't just confidently hallucinating? Who verifies the verifier?
Enter Pattern 3, the supervisor or verifier. This is your independent quality gate. Here is your immediate supervision checklist. 1. Check factual consistency. 2. Verify the internal logic. And 3. Ensure task alignment. If the average competence score drops below 0.75, boom, it immediately rejects the output back to the generator or flags a human. In production environments, this specific pattern caught 92% of silent hallucinations before they ever made it into a client deliverable.
Now, when you're wiring these patterns up, model selection is absolutely critical. You have to rely on objective criteria, not just hype, especially if you want to keep token waste low. For instance, use Claude Sonnet for your orchestration and verifiers. It gives you an incredible cost-to-performance balance and handles reliable JSON schemas like a champ. But you want to reserve GPT-4o for your execution workers, the ones that require incredibly strict tool use and complex external API executions.
Moving on to Pattern 4, the event queue, or pub submodel. So how do you know when it's time to scale from, say, 3 to 5 agents? Look for objective criteria like synchronous API bottlenecks, timeout errors, or sudden CPU spikes. When you hit those walls, you use a queue. Agents asynchronously publish an event, like research complete, and other relevant agents just subscribe to that update.
Since there are no direct calls, failures don't cascade. This is exactly how you evolve from a simple, fragile system into a robust parallel processing machine.
Pattern 5 is the human-in-the-loop gate. Listen, this is your emergency brake. No autonomous agent should ever have unchecked write access to anything that costs real money or directly touches a client, period. In one e-commerce scenario we studied, a rogue agent almost fired off 50,000 cold emails with a completely broken personalization template. But the human gate caught it at contact number 47. That single pause saved the company over $1,200 and a massive PR headache.
So what needs a gate? Here is your risk checklist. Score your agent actions based on financial impact, anything over $50, reversibility, public exposure, data sensitivity, and legal exposure. If it scores higher risk, use a simple automation tool like a Make.com webhook to ping your phone via Telegram or Slack. It pauses the whole system until you literally click Approve.
Finally, pattern 6, idempotent retries. Let's be real. In production, APIs drop, networks fail. It happens. Every single step must be designed to run safely multiple times without duplicating data. If step 3 fails, your system needs to retry from step 3, not start all over at step 1. We use cryptographic hash checks to deduplicate outputs. This guarantees safe operations, so Novacart never double charges a customer or gets sucked into an infinite URL loop.
All right, let's switch gears to Section 3, building this stack for under $50 a month. You don't need a massive enterprise budget for this. This lean, optimized 2026 stack gives you everything you need for under $50. Check this out. Make.com gives you visual routing and retry logic for just $9. Replit hosts your workers with always-on crash recovery for $7. Hostinger offers a $3 VPS to run your Redis Blackboard. Firecrawl handles your scraping for free. Perplexity Pro gives you real-time fact-checking for $20. And FormCarry triggers your human gates for free. It's highly available, it's cheap, and is incredibly robust.
Section 4. The 5 fatal errors. Even with the best tools, you have to avoid these traps. Let's look at the top 5 frequent mistakes that completely destroy agent reliability. First, over-engineering from day one. Please don't build 6 complex verification layers for a simple web scraper. Second, skipping a trace ID system. You absolutely need trace identifiers to debug agent failures instantly by replaying the exact chain of events. Third, forgetting idempotency, which we know causes duplicated data. Fourth, missing that human gate on irreversible actions. And fifth, ignoring authentication rot. Never, ever hardcode your API keys. Protect your sensitive data by using strict OAuth scopes, secure environment variables, and automated credential refresh logic. I want you to internalize this quote. 3 seconds of automated validation beats a week of cleaning up bad client deliverables. After an agent goes through a retry loop, you must validate the final output again. Never blindly trust the loop. Make sure the context didn't get corrupted during those retries. Okay, let's wrap this up with Section 5, your immediate action plan. Let's get pragmatic.
I want you to follow this precise, step-by-step timeline to stabilize your first multi-agent system. Today, I want you to map just one failure mode you're currently experiencing to one of the patterns we discussed. This week, wire up the orchestrator worker pattern and set up a human gate on your single most dangerous action. This month, add the Blackboard and implement idempotency. Don't rush it. Add complexity only when production actually forces your hand.
I'll leave you with this final provocative thought to chew on. Are you building robust distributed systems, or are you just playing around with luxury chatbots? True engineering scales way past the flawless local demo. Take these 6 patterns, wire up those trace IDs, build out that shared Blackboard, and let's go deploy a system that actually survives reality. Thanks for joining this explainer team. Now let's get to work.